So, good day everyone. My name is Jedi Castro from DCPT 31, and today we'll explore the SAP1, or the simple as possible computer system. This is a basic model of how a computer processes its instructions, step by step. And in this video, we'll break down the role of its components, such as this program counter, the instruction register, the MAR, the ROM, and such. And we'll also demonstrate how and see how they work together to execute such following commands like addition and subtractions. So by the end of this demonstration, you will have a little bit of understanding on how this simple yet powerful circuit performs calculation and displays results. So let's immediately head right onto it. So first, I'll be explaining the role of each component and its functionality. So this one is the program counter. This serves as a pointer, keeping track of the next instruction to be executed, and after each cycle, it advances to the following step in the sequence. While here, this is the memory address register, or the MAR. The memory address register directs the memory, or the ROM, here, as you can see, to the specific location where the next instruction is stored, functioning like a mailbox identifier. Now here, moving on to the one of the most important part, the ROM, or the read-only memory. So this is the storage space for all instructions and data, acting as a library that the system refers to during execution. So this is where the the system gets their data, or the, the number to be calculated from. Meanwhile, here is the instruction register. As you can see, we also have a ROM here. So this is the instruction register. So the instruction register interprets and divides each fetch instruction into two components: the operation to perform and the data or address involved in the operation. So next, we have the controller or sequence. This component coordinates the entire process, sending precise control signals to ensure each component functions in sync and at the right time. And here we have the accumulator here, as you can see here. So this accumulator serves as the temporary storage for intermediate data and results during calculations. And underneath that is the B register. So similar to the accumulator, this register also temporarily holds additional data required for operations, such as arithmetic calculations. And here is where the calculation is being done, the ALU, or the arithmetic logic unit. So the ALU is the calculator of the circuit. It is the one responsible for performing operations such as additions and subtractions. Then it sends the result back to the accumulator. Then here, the output register. So the output register displays the final result of the computation, typically on a visual output device such as a 7-segment display, as you can see here. Then lastly, we have here the clock. Here, these two. So the clock regulates the timing of the circuit, ensuring that each step of the process occurs in a synchronized manner. So now that I have explained to you, and now that you know what these parts are, or components are, and their function, I will now explain to you the step-by-step operation on how they perform a calculation. So first, I will explain it to you, then I will demonstrate it to you after explaining. So first is they fetch the instruction. The program counter points to that memory address of the next instruction. The ROM then retrieves this instruction and sends it to the instruction register here. Then, secondly, they decode the instruction. So the instruction register splits the instruction into two parts: the operation to perform, like we said earlier, and the data or address involved. Then the third part is they execute the instruction. So if the instruction involves computation, the data is loaded into the accumulator and B register. Then the A loop processes the data and stores the result in the accumulator. So this is where the calculation happens, then this is where the result goes to. Then the accumulator sends data to the output register here, which update the display on the 7-segment display. Then the fourth is they move on to the next instruction. Since it is, like I said, it is a cycle, so the program counter is increments to the point to the next instruction, and the cycle repeats. Then, when the circuit encounters a halt or HLT, it then stops processing further instruction. So, basically, the SAP1 circuit operates by sequentially fetching, decoding, and executing instructions stored in a memory. It then performs calculations, processes data, and displays results, repeating the steps until a halt instruction is encountered. So despite its simplicity, these SAP1 circuits serve as an essential foundation for understanding on how the modern computer works. So this is basically like a simple mini computer. So now moving on to the demonstration part of this design. So now I will show you how to calculate this 5 plus 11 minus 6, since this is what this SAP1 design is made for, to calculate these following exact numbers. So do you think how can you calculate that using this? So it is actually very simple. So first we have this instruction for this add and subtract. Here, this will determine here. It will show in the controller sequence. If it is 1, then the operation being done is addition. Then if it's 2, the operation being done is subtraction. And here, output EE. So here in the ROM, meaning if this shows in the 7-segment display, it means the output is being calculated. Then if it shows an FF or the halt, meaning the program is done and it has come to a stop. And hopefully the result will be fully shown here by the end of this. So as we all know, 5, if we're just gonna think 5 plus 11 minus 6, so that's obviously 10, right? But how can we be sure that this complex but also simple as possible design computer will calculate those following numbers? So first we'll click this clock here, as you can see here. It will gather it retrieves the data from the ROM, and the ROM and instruction register will change accordingly. As you can see here, we are now on the 8, and the instruction register is showing 8 because it is on this 8 part. And now we have the 5. Here it's showing the memory register 8 because of in this column or row. Then it is also showing 5 on the ROM. So the ROM changes and the instruction register changes accordingly. So 50000101. So as you can see, we haven't set a operation to be used for, but by clicking the cycle, the clock, we will now see the operation to be used. As you can see here, the 19. We are now in the 11 row. Or rather, the 11 column. Here, as you can see, it shows a 1 because 5 and 11, what will we do to that? We were going to add them. So it shows a 1 because the operation to be used is addition. So the controller sections also change according to the operations to be used. And the instruction register in here and in this here and also here is changing accordingly based on the row. Then to get the 11 is here. As you can see, we finally get the 11. And it is still on 1 because we are going to use addition. And the previously 5 that we get is now accumulated into this accumulator. So it is stored here. Then, finally, to get the number 6, here we are in the column of 6. Here, we finally get the number 6. And it is shown here, as you can see, on the controller sequence, it shows a 2, meaning we are going to subtract this. Here, as you can see, 5 plus 11, subtract 5, add 11, then subtract 6 from that. And here, as you can see, the 11 that we get earlier is now here on the B register. Then the calculation that has already been done, which is the 5 plus 11, is now in the accumulator here, which is the result 16. But as you can see, we still haven't got the output register because our system still hasn't come to a halt, meaning the program isn't finished yet. So by just clicking the clock, here as you can see, we're now moving on to the output because it's showing an EE. Here as you can see, the accumulator, it already shows the complete calculation, which is the 10, which is the result we want to get earlier. But now, we are going to transfer it to the output register, then display it to the 7-segment display. Here, as you can see, our program has finally come to a halt, meaning the sequence or the system, the calculation has already been finished and our program has ended and has come to a stop. And here, as you can see, the output register is showing 10 and the 7-segment display is showing 10. And the B register is showing the number 6, which we accumulated from this. So that's it. That's just how you calculate simple addition and subtraction operation using the SAP one or the simple as possible computer design. That's all from me. My name is Jedi Castro and I hope you learned something today. Thank you all so much.